Okay, so what are galvanic cells? Galvanic cell is a device okay, in which a spontaneous chemical reaction takes place, and because of that current is produced. So galvanic cell is a device in which current is produced okay, due to spontaneous chemical reaction taking place in the cell. Okay, due to spontaneous chemical reaction occurs in the cell. Okay, so this is what we call as galvanic cell. Galvanic cell is a device in which current is produced due to spontaneous chemical reaction, okay, occurs in the cell, right? So some chemical reaction taking place, because of that current is produced, right? Or we can also say that here chemical energy is converted into electrical energy. Okay, in galvanic cell chemical energy is converted into electrical energy. Okay, then see any cell, right, whether it is electrolytic or galvanic, it consists of two electrodes. One is an anode, the other one is a cathode. Okay, what is an anode and what is a cathode? This you might be knowing already, but anyway I will just give the meaning for this, then we'll go along. Anode, what is anode? Anode is an electrode where oxidation reaction takes place. Whether it is electrolytic cell or galvanic cell, this is the definition for these electrodes. Okay, anode is an electrode where oxidation takes place, where oxidation reaction takes place. Okay, what about cathode? Cathode is an electrode where reduction reaction takes place. This is the basic difference between anode and cathode. Okay, but this definition is exactly same even for the electrolytic cell. In the electrolytic cell as well as in galvanic cell, oxidation occurs at the anode, reduction occurs at the cathode, no doubt in that. Okay, but one basic difference is there. What is that? Between electrolytic cell and galvanic cell, the difference is in electrolytic cell, anode is cathode is negative and anode is positive. Okay, so I'll write here anode and cathode. Okay, this is in galvanic cell and the other one is electrolytic cell. Let me write here. First one is electrolytic cell and the second one galvanic cell. What about their charges? Okay, during the functioning of these cells, okay, what will be the charge on the anode and what will be the charge on the cathode? Okay, the charge on anode in electrolytic cell, anode charge is positive. Charge on the anode is positive and charge on the cathode is negative in the case of electrolytic cell. Whereas in the case of galvanic cell, just exactly opposite. That is, anode carry negative charge and cathode carry positive charge. Okay, this is the basic difference between electrolytic cell and galvanic cell. Okay, listen, the reaction occurs on the electrode, that is same. Anode always, oxidation occurs always at anode. Reduction occurs always at cathode. This is same whether it is electrolytic cell or galvanic cell. But the polarity or charge on the electrode is not same. Right? So this is very important point, but very basic point also. Okay. Now let me take a simple galvanic cell, that is Daniell cell, and using which I am going to explain how a galvanic cell is working and how it producing current. Okay, we'll discuss all those things. Right? We are going to discuss or understand how a galvanic cell is working. Okay, so for this purpose I am going to take this cell called Daniell cell. Daniell cell. Okay, and to understand, there are many galvanic cells available. Here I have chosen the Daniell cell, which is a very simple one. Okay, and very easy to understand. That's why. Right? Yeah. Now, so what is a Daniell cell actually? See, students, observe carefully. Suppose I'll take in a container, I'll take what is called a zinc sulfate solution. Okay, so it's an aqueous solution. I'll take aqueous zinc sulfate. Okay, very specifically 1 molarity. I'll take 1 molar solution of zinc sulfate in one container, and I'll immerse a zinc electrode here. I'll immerse a zinc electrode. It's a zinc rod actually. It's a zinc solid. It's a rod. So zinc rod here acts as the electrode. Okay, students, observe carefully. The moment you immerse a metal into its solution. What is its solution? Here we have zinc metal, and solution contains zinc ion, correct? Zinc sulfate become ions in solution in aqueous medium. So you will be having zinc ion Zn2 plus and sulfate ion SO4 2 minus. Okay, you will be having equal number of zinc ion and equal number of sulfate ion. Okay, so total positive charge is equal to total negative charge. Each zinc ion carry 2 positive charge. Okay, so initially number of zinc ions, number of sulfate ions are exactly equal. So the solution is neutral. Okay, when you immerse a zinc rod in this solution, what will happen? Okay, there is a natural tendency that metal will undergo, right, will lose electron and undergoes oxidation. So what will happen? Zinc will lose electron and undergo oxidation. Okay, so you'll get zinc 2 plus ion and 2 electrons are released. And these zinc ions present in the solution, they gain electron and the backward reaction also sets up. Students, observe carefully. Zinc metal, which is present in the electrode, right, undergoes oxidation and produce zinc ion and 2 electron. The zinc ions present in the solution gains the 2 electron and becomes zinc. This is a reversible reaction. This reversible reaction is set up. Okay, once you immerse the zinc rod in the solution. Okay, you will get an equilibrium, right? You will get an equilibrium, that's all. Now what will happen, student? What I am going to do, I will take another container. I will take another container. In this container, I am going to take an aqueous solution of copper sulfate. I will take aqueous copper sulfate. Copper sulfate ionizes to give cupric ions, Cu2 plus ions, and sulfate ion, SO4 2 minus. Now what I am going to do, I will immerse another electrode here, which is actually a copper rod or a metallic copper plate. So copper solid. So here copper is immersed in copper sulfate solution. What will happen here? The moment you immerse the copper electrode in cupric sulfate solution, right? As like here also copper will undergo the copper atoms present in the metal undergoes oxidation, gives you cupric ions and release electrons. and release electrons. And these cupric ions present in the solution, this is aqueous. The cupric ion present in the solution gains 2 electron and become copper. Here also this reversible reaction setup. Okay, this is happened just to immerse any metal into its solution. Okay, our solution containing the metal ion. Right. So here you will get an equilibrium, here you will get an equilibrium, then the reaction remains at equilibrium. Now what will happen, student? I am going to connect the 2 electrode externally using a wire. And I'll also connect a voltmeter here. I'll connect a voltmeter, right? And I'll join the 2 electrodes. The moment you join the 2 electrodes, students, observe carefully. You might have heard about reactivity series, right? In your lower classes, you might have heard about reactivity series, right? Reactivity of one metal and reactivity of another metal are not same, right? Reactivity differ from metal to metal. So when you connect the 2 electrode through an external wire, what will happen? One electrode will undergo oxidation, the other one will undergo reduction. Here, student, in this reaction, see, forward reaction is oxidation, reverse reaction is reduction. Here also forward is oxidation because electron is losing electron, copper atom losing electron. So forward reaction is oxidation, backward reaction is reduction. But when you connect the 2 electrode through a wire, then predominant oxidation takes place at one electrode and predominantly reduction takes place at the another electrode. Okay, actually reactivity of zinc is high. So oxidation in this container, oxidation is the dominant process. Okay, right? So here what will happen? More and more oxidation starts to occur. Right, students, observe carefully here. When one zinc atom, see, I'll just draw the metal alone, the metal electrode alone here. The metal electrode has a lot of zinc atoms. When one zinc atom, right, undergoes oxidation, zinc atom present in the solid undergoes oxidation. Okay, you'll get zinc ion and it will release 2 electron. Okay, students, I often say this: electrons do not know swimming. Electrons do not know swimming. Therefore, the electrons released by the zinc atom remains on the electrode, whereas the zinc ion, okay, it will enter into the solution. So when zinc atom present in the electrode undergoes oxidation, you will get zinc ion and 2 electrons. Zinc ion jump into the solution. Zinc ions jump into the solution, and the released electrons, okay, it remains on the electrode. Okay, here I have shown only one atom, but the moment you connect the 2 electrode, many atoms starts to undergo this oxidation process. So you'll get many electrons remains on the electrode surface, and the ion starts to jump into the solution. Now what will happen, students? When one zinc ion jump into the solution, see, already the solution contain equal number of zinc ion and sulfate ion, right, at the beginning. Right, at the beginning, number of zinc ion, number of sulfate ions are equal, so net charge on the solution is 0. But now one zinc ion is entered in the solution. Okay, or few zinc ion entered into the solution. Now what will happen? Number of zinc ion become more than sulfate. So zinc ion carry positive charge, therefore the solution become positive. Right, the moment the solution become positive, it will never allow further zinc ion to enter into the solution. It never allow further zinc ion to enter into the solution because the solution is positive now. Zinc ion also positive. Positive starts to repel. Okay, so immediately this oxidation reaction takes place, stops. Okay, so here the dominant reaction is oxidation. Why? Because reactivity of zinc is greater compared to copper. Okay, oxidation is the dominant process. So I am writing only the oxidation reaction here. Because of oxidation, students, observe carefully, zinc atom present in the electrode loses 2 electron and becomes zinc ion. Zinc ions jump into the solution. It will go into the solution. Whereas the electrons do not know swimming, so they remains on the electrode. Okay, right now since zinc ions are entering into the solution is become positive. Why the solution become positive? Because at the beginning number of zinc ion, number of sulfate ions are equal in number, so net positive charge and net negative charge are equal, so solution is neutral. But the moment you connect the two electrode, right, few zinc ions enter into the solution, so the solution become positive. Once the solution become positive, it will never allow further zinc ion enter into the solution. Therefore, this oxidation process just stops. It does not occur further because solution is positive. And now the electrode carry lot of negative charge, correct? Students, that electrode surface now has many electrons. Electrons carry negative charge. Therefore, the electrode charge is negative. Why the electrode charge is negative? Because the electrode now contain lot of electrons. And what is the reaction occurs here? Oxidation reaction. Whenever oxidation reaction takes place, we call that electrode as anode. I have told you, anode is an electrode where oxidation takes place. Okay, so at this zinc, right electrode, oxidation reaction takes place. Therefore, this electrode is an anode. But now anode carry negative charge. See this. Anode carry negative charge. Similarly, what happens here? Here, oxidation is not the dominant process, because the moment you connect the two, okay, the reactivity of zinc is high. Therefore, zinc undergoes oxidation, and dominant reaction that occurs here is the reduction. Okay, what will happen? The cupric ions present in the solution, let me write here. Dominant reaction here is reduction. What is the reduction reaction occurs? Cupric ions present in the solution gains 2 electron. Okay, gains 2 electron from the metal, right? See, each cupric ion approach the metal and it gains electron. It gains electron from the metal, right, and get deposited on the metal. Cupric ions, they approach the electrode and gains 2 electron from the metal, okay, and get deposited on the electrode. But now, since the metal loses 2 electron, to reduce this cupric ion, metal losing 2 electron, therefore the metal become positive. Let me draw and show you here. See what is happening here. In this electrode, we have copper atoms or copper metal rod and the solution containing cupric ion. Right? When cupric ion approaches the electrode, what will happen? The electrode releases 2 electrons. The electrode, or I can say the other way, the cupric ion gains 2 electrons from the metal. Therefore, the metal gets positive charge. Students, observe carefully. Each cupric ion gains 2 electrons from the metal and undergo reduction. Right? Undergoes this reduction reaction. So, you will get copper atom. These copper atoms get deposited on the metal surface. But since the metal loses 2 electrons for each cupric ion, the metal gets positive charge. Okay? The reaction occurs at this electrode now is the reduction reaction. Therefore, this electrode is called the cathode. Cathode is an electrode where reduction reaction takes place. And what is the charge on the cathode? Charge on the cathode is positive. Okay, charge on the cathode is positive. Very, very important. This is how the charges are developed on the electrode. But students, observe carefully. Here, at the beginning, number of cupric ion, number of sulfate ions are equal. So, net charge in the solution is 0. But when the cupric ion starts to deposit on the electrode, what will happen? Number of cupric ion decreases. Therefore, okay, listen student, the reason is this. Due to oxidation, this solution become positive because excess zinc ion entered in the solution, so solution become positive. Because of that, the oxidation reaction just stops. What happened here? Due to reduction reaction, cupric ions get reduced. Therefore, number of cupric ion is less now, so solution become negative. Because of excess sulfate ion, solution become negative. Therefore, reduction reaction also just stops. Right? To carry the reaction, or to for the reaction to occur continuously, what we have to do? We have to neutralize the solution. We have to neutralize excess positive charge here, and we have to neutralize the excess negative charge here. For this purpose, okay, we immerse an apparatus called salt bridge. What is salt bridge? Usually salt bridge contain an agar-agar gel with saturated potassium chloride. Very simple. You take agar-agar gel, add some hot water, make it into you take agar-agar powder, mix it in hot water and make into gel, then add excess of potassium chloride. Okay, mix continuously, you will get a gel. Suck the gel, suck into this tube and dry it. Okay, you will get what is called the salt bridge. What is the purpose of salt bridge? Yes, we are going to discuss. The salt bridge is immersed in the two solutions like this. Once you immerse, what will happen? Students, observe carefully. From this side, see, this solution is positive now, right? So to neutralize this positive charge, chloride ions will enter into the solution. Chloride ions enters into the solution. Chloride Cl minus. Why? Solution is positive. So to neutralize the positive charge, chloride ions are entering into the solution. Similarly here, the solution is negative now. To neutralize that negative charge, potassium ions entering in the solution. Students, observe carefully. To neutralize the charges, excess charges present in both sides, we are immersing an apparatus called salt bridge. When you immerse salt bridge, what will happen? Chloride ion enters here. Chloride ion carry negative charge. Solution is positive now. So when chloride ion enters, what will happen? Solution get neutralized. Once solution get neutralized, then further oxidation starts. Okay, so now oxidation occurs continuously. What happens here? In this side, cupric ions are entering into the solution. Right? When cupric ion enters into the solution, what will happen? I'm very sorry, copper ion. I'm sorry, K plus ion, potassium ion. K plus ions are entering into the solution. K plus ion carry positive charge. And you know, this solution already become negative. Once the K plus ion enters here, the charge get neutralized. Once the charge get neutralized, then further cupric ion starts to undergo reduction. So again, the oxidation reaction at zinc electrode and reduction reaction at copper electrode starts to occur continuously. Okay. Now students, observe carefully. Because of the oxidation, okay, electrons get, right, this side you'll get negative charge because many electrons are produced and these electrons are accumulated here. Okay, students, observe carefully. I'll just write in the next page. This is another important part you should know. See, I'll write separately and show you what is happening in both the cell. Observe this carefully. Okay, now the electrode, that is zinc electrode, it is actually the anode, where the electrode surface now contain lot of electrons. Okay, so this is actually zinc rod. Zinc rod now contain lot of electron because oxidation occurs here. Zinc ions enter into the solution. Zinc ions enter into the solution, whereas the electrons do not know swimming, so it remains on the electrode. Now students, observe carefully. So now this electrode is carrying lot of negative charge. Electrode carrying lot of negative charge. Okay, this negative charge, right, appears or form a layer. That layer is what we call as a primary layer. A primary layer of negative charge is set up. What this primary layer will do? It will attract the positive ions present in the solution. Students, can you tell me what positive ion is present in the solution? Can you tell? So what will happen? These zinc 2 plus ion, okay, they are attracted by the negative charge of the electrode and they form another layer like this. They form another layer, zinc 2 plus. Just for understanding purpose I am drawing like this. Okay, another layer. Students, another layer throughout the on the surface of the electrode, and this forms what is called the secondary layer. A secondary layer is formed and the secondary layer is positive now. Listen student, observe carefully. Because of oxidation, okay, oxidation occurs here, okay, and this is the anode. Okay, anode is the electrode where oxidation takes place. Okay, because of oxidation the electrode gets negative charge, that is called the primary layer, and this primary layer attract the positive ion present in the solution. So the positive ions goes closer to the electrode and they form another layer called secondary layer. So here primary layer is negative, secondary layer is positive. Because of these two layers we call this as double layer. Actually it is called double layer. Whenever electrical double layer is formed, a potential is developed. Students, observe carefully. Whenever two charges exist very close, a potential is produced. Here we have a layer of charge. One layer is negative, primary layer is negative, and secondary layer is positive. Because of the electrical double layer, it is called electrical double layer, an electrical double layer is formed. Electrical double layer is formed, and that electrical double layer gives a potential, and this potential is called the oxidation potential. Why it is called oxidation potential? Because this double layer is formed due to oxidation. This electrical double layer is formed due to oxidation. Therefore the potential developed due to this double layer is called oxidation potential. So an oxidation potential is developed here. What happens in the other side? In the other side, students, observe carefully. Due to reduction reaction, the electrode gets positive charge. Why? Because cupric ions approach the electrode. Cupric ions present in the solution approach the electrode, gains 2 electrons from the metal and get deposited as copper. Therefore, since the metal loses 2 electrons for each cupric ion, the metal gets positive charge. So let me draw separately like this. So the metal gets positive charge now. Metal gets positive charge. Throughout the metal surface we have positive charge. So this forms a primary layer. So here the primary layer is, here the primary layer is positive. Now what it will do? This primary positive layer will attract the negative ion present in the solution. Students, tell me what negative ion present in the solution? SO4 2 minus ions. These are the negative ions. They form the secondary layer. They form the secondary layer. SO4 2 minus. SO4 2 minus. Okay. So throughout the electrode, okay, you'll get a secondary layer. So this is the secondary layer. Secondary layer of charge. And the secondary layer, it is a sulfate ion. Sulfate ion carry negative charge, no? So secondary layer is negative. Now see here, like anode where we get an electrical double layer, similarly at cathode also, here this is cathode. Copper acts as the cathode, okay, where reduction reaction takes place. Because of the reduction reaction, you will get a primary layer of positive charge on the electrode and a secondary layer of sulfate ions, okay, which comes closer to the electrode and form a secondary layer. Okay, so you'll get electrical double layer here also. Because of this electrical double layer, another potential is set up here, and that potential is what we call as reduction potential. Why it is called reduction potential? Because this electrical double layer is formed due to the reduction reaction occurring in the cell or occurring at this electrode. Okay, students, observe carefully. So you will get an oxidation potential here and you will get a reduction potential here. Now what will happen, students? Due to the potential, Okay, due to the potential, suppose if there is a difference in potential, then what will happen? The electrons which are produced at the zinc electrode, they starts to move. Okay, they starts to move through the wire. Okay, electrons move from anode to cathode. Electrons move from anode to cathode. So what will happen as the electron starts to move? The accumulation of negative charge decreases. Therefore, further zinc atoms starts to undergo oxidation. Okay, so oxidation reaction continues. And here, when the electrons enter here, what will happen? It will neutralize the positive charge here. It will neutralize the positive charge. Therefore, accumulation of positive charge also reduced. So reduction reaction also occurs continuously. Okay, so students observe carefully. Observe carefully. This is the salt bridge. Okay, so here you will get an electrical double layer due to oxidation. Here also you will get an electrical double layer due to reduction. Okay, and because of the electrical double layer you will get a potential, right? Due to oxidation you get an electrical double layer. That potential is called oxidation potential, and due to reduction you will get a potential here that is called reduction potential. And student, we have taken 1 molar zinc sulfate here and 1 molar copper sulfate here. Both are 1 molar solution, and temperature is maintained at 25 degrees Celsius. Students, this is another important point I like to say. Because of the we have taken 1 molar solution and temperature is maintained. Temperature is not important, but by convention we maintain temperature as 25 degrees Celsius. When you take 1 molar solution, okay, then whatever potential that is produced at the voltmeter is what we call a cell potential. Because electrons are moving here, you know very well, if electron moving from anode to cathode, the direction of current is here. Okay, current I, right? By convention we say that current is moving in this direction. Okay, you will get a potential, and that potential is what we call a cell potential. Okay, you will get a cell potential. Students, observe carefully. You will get a cell potential. Now let me write the next page. Cell potential is developed. Okay, and here students, we have taken 1 molar zinc sulfate solution and 1 molar copper sulfate solution. Therefore, this cell potential is also called a standard cell potential. Standard cell potential, which is represented by the symbol potential. We represent potential by the symbol E. I'll put a naught in the superscript, which means a standard, and it is a cell potential, so I'll put a cell here. So standard cell potential E naught cell, it is represented like this, and in the Daniell cell 1.1 volt potential is developed. Okay, take down. Standard cell potential is nothing but the sum of oxidation potential occur at anode and the reduction potential occur at cathode. Okay, IUPAC recommends that we should use only reduction potentials. Okay, only reduction potential should be used. Potentials must be used. This is the IUPAC recommendation. Therefore, we should strictly follow this. So, we should not consider oxidation potential at all. We should consider only the reduction potential. So, what I am going to do, E naught cell equal to, right? When you convert oxidation potential to reduction potential, what you have to do, you just change the sign, that's all. So, negative sign I'll put, negative sign, and E naught reduction potential of the anode plus E naught reduction potential of the cathode. Actually, at one electrode oxidation potential is developed, but why we put reduction potential? The reason is due to the IUPAC recommendation. Okay, so E naught cell equal to, we can also write this as, I'll write this positive first. Okay, so E naught reduction, hereafter you need not write reduction potential because it is reduction potential only. According to IUPAC, we should use only reduction potentials per electrodes. So I'm not going to write red and all. I'll just simply write E naught cathode minus E naught of anode. E naught cathode minus E naught of anode. Right, students? This is very important. Right? I'm going to say that while writing galvanic cell on a paper, you must write always like this. That is, we represent salt bridge by a double vertical line like this, parallel lines. This double vertical line indicate salt bridge. And we always write anode in the left hand side and cathode in the right hand side. This is called the cell representation. We are going to discuss that. According to cell representation, see students, cathode is always present in the right hand side and anode is present always in the left hand side. So instead of writing cathode, anode and all, I can simply put R and L here. So what is E naught cell? E naught cell equal to standard reduction potential at the right hand side electrode minus standard reduction potential at the left hand side electrode. Okay. Now what is the definition for cell potential? Very simple. It is the difference in reduction potentials. It is the difference in reduction potential occurs or formed at the electrodes. Okay. That is reduction potential developed at the right hand side electrode minus reduction potential developed at the left hand side electrode. The difference between these two is what we call a cell potential. Okay, so cell potential is the difference between the two electrode potentials developed at the electrodes. Okay, right? In a cell, at one electrode oxidation takes place and the other electrode reduction takes place. No doubt in that. But what IUPAC says is that we must use only reduction potentials, just to avoid confusions. That's all. Right? Therefore, here this E naught R, E naught L, both are actually reduction potentials. Okay, reduction potentials at the right hand side electrode. Right hand side means cathode. Minus reduction potential at the left hand side electrode, that is anode. We should consider only reduction potential here. So if you consider only reduction potentials, then the difference between these two is nothing but cell potential. So we often define cell potential like this. What is cell potential? Cell potential is the difference between electrode potentials developed at anode and cathode. Simple. It's the difference. Okay. Yeah. The difference between the electrode potential is what we call a cell potential. Right? Now, okay, let me give some information about salt bridge, then I'll come back to the cell potential again. Okay, salt bridge. See, salt bridge is a glass apparatus. Okay, salt bridge, I'll just write SB. SB means salt bridge. Salt bridge is a glass apparatus, a glass tube actually. So glass tube contains saturated potassium chloride or saturated potassium nitrate or saturated ammonium nitrate. Okay, you can take potassium chloride or potassium nitrate or ammonium nitrate in agar-agar gel. Agar is a polysaccharide. Okay, in this polysaccharide gel, we'll mix the polysaccharide in hot water. We form gel. In that gel, we add saturated KCl and we'll mix it continuously. Okay, then that gel is sucked in the glass tube, then the glass tube is dried, you'll get what is called salt bridge. Now the question is, why we take salt bridge? What is the use of salt bridge? Salt bridge neutralizes the accumulation of excess positive charge. I don't want to use the word excess. Accumulation of positive charge, okay, at anode, and accumulation of negative charge at cathode. Right? Because of this, what will happen? The cell works continuously. Therefore, cell works continuously. Right? Then the next important question, that's the purpose of salt bridge. Then the next important point you should note here is why we are taking potassium chloride. Why we are taking potassium nitrate? What is the reason? The reason is, listen student, potassium chloride, saturated potassium chloride will give potassium ion and chloride ion. These ions, they have almost, the mobilities of these ions are almost equal. Right here, mobility of potassium ion is roughly equal or almost equal to the mobility of chloride ion. They have same mobility. Since the mobilities of these ions are almost same, what will happen? These ions are moving in the opposite direction, right? See, I have told you, in the cell, chloride ion is moving, right? Inside the salt bridge, chloride ion is moving in this direction and potassium ion is moving in this direction. The ions are moving in the opposite direction. Because of that, there is a potential developed called liquid junction potential. Liquid junction potential, this potential will also appear with the cell potential, but we don't want this. We don't want liquid junction potential. To eliminate liquid junction potential, we use what is called salt bridge. Why? How we eliminate? Because the ions move with same mobility in the opposite direction. Therefore, the liquid junction potential becomes zero. So the purpose of taking salt bridge is not only neutralizes the excess charge, okay, it also eliminates salt bridge eliminates the liquid junction potential developed at the cell. It eliminates the liquid junction potential. This is another important point you should remember. Okay, take down. What is the purpose of salt bridge? Salt bridge is a glass tube, contains saturated potassium chloride or saturated potassium nitrate or saturated ammonium nitrate in agar-agar gel. Okay, and salt bridge neutralizes the accumulation of positive charge at the anode and accumulation of negative charge at the cathode. Therefore, cell works continuously. Not only that, why we are taking potassium chloride? We have lot of electrolytes. Sodium chloride is there, calcium chloride is there. We can take anything. But why we prefer potassium chloride? Because potassium ion and chloride ion, the mobilities of these ions are almost equal. Why we are focusing on mobility? Because these ions move in the opposite direction. If they move with the same mobility, almost same mobility, what will happen? The liquid junction potential does not appear. It becomes zero. So to eliminate liquid junction potential, we are using potassium chloride. Okay. So you may ask a question, sir, why we are using potassium chloride here? The reason is this. If you use potassium chloride, since mobility of potassium ion and mobility of chloride ion are equal, almost equal, we can eliminate the liquid junction potential. So whatever potential that is appearing in the voltmeter is actually the cell potential. Okay.